uh, entropy or Gini index. One of them we have considered as a split measure, and we computed the gain based on each and every attribute. So with reference to which attribute the gain is maximum, we decided that we will split on it. Accordingly, we just got the algorithm. We said if stopping condition EF is true, then where your E is the training records set and F is the attribute set. So all the attributes are kept in F and all the training records are kept in E. That is how we have considered. So that the starting set is your tree growth with the total number of records and the attribute set F. With that we start. Then if the stopping condition of E and F is true, then you create a leaf node and you label it. So you classify that as the label with maximum elements that we thought of, and you will return the leaf. Okay. The stopping condition is that we have, if all the attributes have the same class label, or if the number of records there is equal to the threshold value, because it should not be less than threshold value what we have decided. Okay. Then we said, or else if it has got equal attribute values on the split condition, you cannot split it on that line. Okay. If the same value is there, then you make a leaf node with that. Else you will be recursively going ahead with it. So initially if you start with, the stopping criteria will not be met. So it comes to the else part. Then you say root is create node and root dot test condition is find the best split. To find the best split, you will pass on E and F. So that means the records, and the F is the set of all attributes. Okay. So you will find out the best split on each and everything for that set of E, and then you will create a set V that consists of V, which is possible outcome of root dot test condition. So that means you will have the, what is the possible outcome of your test condition? You will say that yes, this is the condition, because on which attribute you have to put and which is the best. Suppose it's a continuous variable, you have that table, right? We have studied in previous class. As per that you will decide the test condition, okay, which is the best split, because you may have binary split and multi-way split. In multi-way split also have combinations, small and large, medium, small, medium, large, like you have certain sets. So which is the best condition suited for that, you will keep it in the V. And for each V that belongs to V, you will do that the test condition, that part, because satisfying that condition you have to split, right? You have 100 records, let us suppose. Your test condition is that sum is x greater than 50. Then you will have two segregations. All x greater than 50 will be on one side, not greater than 50 will be there on the other side. So it will be split into two. So you will be checking that, and EV is that kind of split. That means for every condition, possible condition, you will split them. So you will have 60-40 or 70-30 or 65-35, 66-34, like some split will be there. They are EVs, right? Then the child is tree growth EV with F. So what is becoming the child? What will be the child now? You have the test conditions, two test conditions, less than or greater than. So which are all less than? Some 55. Then grow a child for with those 55. And for remaining 45, you grow another child. Recursively that goes. Then once these things are there, for each one you will again test the E growth. That means whether it can be split further or not checked. If the stopping condition is there, you will stop it there. It is not there, you recursively keep on dividing this. That's how the algorithm works. That's what I explained yesterday. Of course, in yesterday's class, if you have any doubts, you can just ask me so that I can go ahead with that, because as a recap, because this being the algorithm, I just gave a quick recap of what we did. So if you have any doubts here, you can ask me so that I can proceed further. Next slide, please. Shall I keep it for your reference, the algorithm part? Okay, you keep the algorithm part. Yes, in last class, somebody asked me why the Gini index is it an expansion or what is the reason for it? Actually, it is not the expansion or is not an acronym. It is the name of a statistician. Corrado Gini is an Italian statistician. In 1912, he published a paper on income distribution. So he has introduced certain measures for distributedly checking up the disparities in the income of the country people. So regarding that, he published a paper and he introduced a measure. So that is named as Gini index for that. So it has been used here as a condition for our problems also subsequently in classification and regression. So that kind of index has been taken. That is 1 minus t square we have. 1 minus the probability square that has been managed. And once this is done, I will be telling you I'll be giving you the derivation for entropy. Okay, why it is minus P naught. So it's okay with you? So I'll move to the next step, please. From affiliated colleges, you can post me or the chat if you have any questions. I think the friend who asked me last time got his doubt clarified, I think. Okay. Anyway, thank you very much. I never worried about why the thing has come into picture from past few years. But you just reminded me why it is named. It is a good thing anyhow to know the history of something. So I appreciate your concern about asking me. Okay. See, these are the methods we have used: create, note, find the best fit, classify. So how do you classify? Whatever is the maximum value you have in this, which class has maximum representative samples, you say that leaf belongs to that class. So that means if the condition is being satisfied in that direction, that goes to that specific class. We'll do that because exactly we will not have all the records of same class segregated into some group. It's not possible because a statistical thing, right? It's not an exact science. So this is the and stopping condition is the function that is used to terminate the tree growth. I said when all the labels are identical or you have the conditions like same class label or the same attribute values. Another way to terminate is to test whether the number of records have fallen below some minimum threshold. Why you need some minimum threshold is there should be a strength for your argument. Okay. We will see, in fact, that causes a overfitting problem if the minimum number of representative samples are not there. Actually, in my next example here, I will be showing you that part also. If you too much fit the training data, it's overfitting, it's called. What happens, like I'll explain. Okay. So there is a stopping condition, and there are 3 pruning steps we can take up and all. The overfitting problem I tell you. That part we will be discussing subsequently. Before that, I would like to show you the derivation. So you keep this aside, and yesterday I have given the derivation concept. Derivations on PDF files. This is derived from a subject called information key. You have a subject called information key, is studied by electronics. So from there, this has been derived. Because what is that you are saying, your entropy is sigma minus P Pi log Pi, I running from some 1 to k. If there are k classes, that means there are k distinct classes. So handwritten derivation. Okay, why is this? So why is this? Why not something else? The formula. This is a very pricking one for all the people. I felt it is better to know that so that your analysis enhances. Okay. See, here the logic is, suppose I say sun rises in the east. What is the probability for this event? 1. Does it carry any information for you? Any special thing? It's a universal truth. You don't gain any special information. Okay. What he says is, a dog bites a man. It's also very common, that is happening in papers also. Right? But if somebody says man bites a dog, it's a rare event. So that means you have some information carried. Okay? So that means information will be carried to you by rare events only. So rare event means its probability is less, right? So if you say of some event xi is happening means, let P be the probability of xi. Okay? So Pxi is the probability of some event to happen. Okay? Now, so the information that is carried through xi, we said it is inversely proportional to the probability of its event. Suppose if I say sun rises in the east, probability is 1, it always happens. But at some point of time, if you say that it happens 1 in 5,000 years, sun rises in the west on that day, okay, and something happens, the stars will be visible, something if you specially say, it's a very, so it's an event that is carrying lot of information, right? It's carrying lot of information. So hence we say that information xi is proportional to 1 by P of x, right? Because we said inverse proportion. Inverse proportion means 1 by P by x. So 1 by, laptop lo rakkame ikkada maamuluga chuvinchesi ila enni. Okay, this proportion to, or else your I of xi is a function of 1 by P of x. Okay, is a function of P of 1 by x. You know very well that if there are two independent events, two mutually independent events, that means you have one more event called small yk. This is another event. then what is the probability of, rather the information that can be carried out of y, IYI is a function of 1 by P yk, right? Do you agree for this? Yk is another independent event. Its probability is P of yk. So the information carried out by that is function of 1 by this thing. Now, what is the probability of both the events happening at any time? If I say probability of one event to happen, two events to happen, two independent events to happen, what is the probability? One event probability is P1, another event probability is P2. If they want to occur simultaneously, what is the probability? Independent events, P1 into P2. The product, two independent events, right? So, the probability of both the events happening is, suppose P of xi comma yk, if you say, that is equal to P xi into P yk. Do you agree for this? Do you agree for that? Is it okay? So, this is the combined probability of two events happen. Now, if you consider the information, see, so your P of xi comma yi is P of xi into P of yk. Okay. Please remember that is small yk. Okay. Small letter y. Now, the information carried out of xi and yk of both the things should be inversely proportional to or is equal to function of 1 by P xi yk. Okay. So that is equal to your function of 1 by P xi dot P yk. Do you agree for that? This is the one. P xi 1 by P xj into P yk. So this derivation is available in Information Theory textbook by Shannon. It's a very popular textbook followed for information theory by electronics. From that only I have taken small pieces of it, just to explain. Because they have a lot of other stuff like information passed through bits, bytes, and a lot of other stuff is there. That's not our concern. Only the part that is related to us I have taken, just as a derivation. So, you are convinced very much that the information of that is equal to f of pxj into pyk, because that is p of xj yk. You have derived p of xj xi yk is p of xi star p of yk. Is it okay for you? Right? My dear friends, if you have any problem with understanding this or something, you can just put me on your chart. The last time I am very happy you have put certain things on chart, even though you are not able to communicate through video. So don't hesitate to ask them our chart. Now, Pxi, Pyk, this is the function of this inverse. Now, if you look at your information of xi and yk, you capitalize y, capital Yk. Just we called it as capital Yk. Now, it is, if you consider the information, suppose you have two events. So the total information that is carried out of these two messages is sum of the information, right? That is obvious, because one message has got some information, the other message got some other information. So the total information you get is equal to sum of informations of these two. I hope you will agree for that. No dispute on that. So your I of yk is f of this thing. Now your I of xj yk is equal to I of yk. This is equal to, before I show this, one step is just being omitted. Okay, from this I can show you, because due to shortage of space, I have omitted the steps. But here the step is, one more step which we omitted is, your I of xi yk or your I yk, capital Yk, is equal to I of xi plus I of small yk. Do you agree? Because the information that is being carried by two messages will be the sum of the information carried by both. You agree for that, right? So it should be like that. Now, so far we are saying f is that much only. But what should be this f to make this in that fashion? Because you are saying the division part, but at the same time it should satisfy the condition such that your I of capital Yk is equal to I of xi plus I of small yk. So you choose your f in such a way that this is satisfied. This is the criticality here. Do you agree? This is the point you have to understand. You have to choose your f in such a way, because it is here, the probability is the product part, no doubt about it. So this is the product part, but at the same time the information should be summed up. So if you choose the f to be log, if you choose the function to be logarithm, then what happens? Your f of 1 by pxi into pyk will be logarithm of 1 by pxi to pyk. So this will be equal to log of 1 by pxi plus log of 1 by pyk. Do you agree for this? If it is logarithm, this can be split like this comfortably. If it is something else, you can split it that way. You don't know. Agree? So this becomes like this. This is nothing but log of 1 by pxi is your ixi, your iyk. This is. So that means you have chosen the f such that the information sum is equal to the total information. Okay? So if it is the log function, this will be fine. So the amount of information is of any event is I of xj, that is equal to log of 1 by pxj. That means it is minus log p of xj. Do you agree? For any event to happen. So it is minus p of minus log pxj minus log pyk of two sets means. Do you agree? So for every set, the probability of it multiplied by that. Okay, now here you will come to the actual part of the derivation. Here the assumption is you are sending some messages m1, m2, etc. m. Okay, some m messages, your capital M messages you are sending, m1, m2, etc. small m, capital M. Those many messages you are sending. Okay, say that the probability for every message to occur is P1, P2, etc., PM. They are the probabilities of each and every message. Are you following here? You have M messages to be transmitted, and the probability of each happening is capital P1, P2, like that is a probability. Now, we consider a substantially long time interval L, where this L is much greater than M. That means your M is suppose 10 messages, let us suppose. Your time span L is maybe some 10,000 minutes, like, okay, or a few days, something, okay. So that L is a substantial figure, substantially bigger figure than your M, okay. In such case, what happens? These are the messages. So these are, you want to calculate the information passed on through this set of messages. So now if you consider how the things will come into picture. The message M1, M2, M2, etc. are there. So the message M1 may go some number of times. That may be transmitted. M2 could be transmitted again some number of times. M3 could be some number of times, because they need not have equal number of transmissions. Now if you consider for each message, if you consider the number of messages of M1 during the period L will be the probability P1 into the L. Probability is in unit time, how many times it can be passed. So in a time length of L, that probability into L times the message can be transmitted. What is the probability of this transmission means? Probability P1. That is the P1. If you multiply that with L, okay, that is the probability of transmitting this message. That means those many number of times the M1 message can be transmitted. Similarly, M2 with P1, P2L, P3L, etc., PML. Now, the amount of information in one single message is log 1 by P1. M1 is log 1. M2 is log 1 by P2. Okay. Now, if you consider the total information of all M1 messages is P1 into L into log 1 by P. Agree for that? Because the number of messages M1 is P1 into L, those many messages. Each has got an information of log 1 by P1. So this is P1L into log 1 by P1. These many M1 messages will be transmitted. So the information will be that much. So the total amount of information IT is equal to P1L into 1 by, log P1, log P1, I'm sorry for that. P2L into log 1 by PML into log 1 by. Now the average information will be your total information divided by L, the time period. So the L gets cancelled everywhere. So the total information passed is P1 log 1 by P1, P2 1 by log P2 plus P1 log 1 by P. So this is equal to your sigma k one running from Pk log 1 by Pk. That is equal to minus k is equal to 1 to m Pk log P. Okay. Are you convinced with this? So minus sign is taken out, minus of sigma of Pk log Pk, k is equal to 1 to m. Or we call it as I is equal to some 1 to m Pi log P. Okay. Here, if it is transmission of bits, you consider the base to be 2. So log to the base 2 we consider. See, if you look at also in my previous examples, I have shown you the curve for Gini index and your entropy are having the same shape. Only thing is the amplitude differs. That means what I would like to say is you chose f to be log here, but you can choose the function, any other function, in such a way that the sum is the same. So need not necessarily be log. Okay, you can so choose that the sum is, information sum is equal to, in such a way, if you choose f, you will get different measures. So once you choose this f to be log, you call this as entropy the measure, right? Even with the Gini index also, it is being summed up, right? The Gini index formula. That's why the shape is one and the same, the amplitude differs. Okay. So this is the derivation of why it is minus p log p, right? Is it clear to you? Take out this. You can come back to the original position of this thing. Oh, no, not today's class. Still we have to be there. Right? You go to the model overfitting on the open chat. Because why I am following from this textbook diagrams is, in the PPT the diagrams were a bit different, explained. First half is identical to that of textbook. So in order to avoid the confusion for you, I thought, and PPTs you have some extra information also. I thought I'll show you from the textbook part exactly, so that with reference to your syllabus you will not have any confusion. Okay? Because you don't have all the topics in curriculum. Because if you look at the syllabus, you will know which topics are there. They are being clearly mentioned. Okay, which topics are there. So this kind of classification, that example, these things are not there in the syllabus. We have gone to the model overfitting because the content is more here. So we thought which is appropriate for you can be shown. So you can still move forward. Overfitting, come back. Come back. Come back. Come back. Next slide. కిందకి రండి ఇంకా. నెక్స్ట్ స్లైడ్కి రండి. 28. నెక్స్ట్ 29. ఇప్పుడు రండి. Now here we have a problem called next చూపించండి. వెనక్కి రండి. You face couple of problems with reference to the model, because you have built up the decision tree and all, you are going ahead with, but you have a lot of questions. Okay. How to, first of all, what are the problems we face with this decision tree? Is it exactly fit for us? How fit it is otherwise? Because I said the decision trees are not good. Right? I said that the decision trees are not good. Then in such case, you will obviously get two things. One is, what are the difficulties you face with reference to building the decision tree? How to overcome the difficulties? Then, how do you evaluate the model? Because these are two obvious things, right? Once you want to do any job, forget about decision tree. Suppose you say you derived something for solving some problem. some methodology. Obviously, you have to know what are the challenges in that methodology. Do you agree with me? What are the challenges you have in the methodology, and how do you evaluate what you have done is right? Because suppose you develop a program, what is that you will do? First of all, you will test it and find out whether it is correct or not. That is one thing. And once you found that it is correct, the next step is you have to find out whether it is how accurate it is. Suppose there are 2-3 other models, how to compare the accuracy of those. So these are few issues one has to observe and consider. You agree with me? So now we are considering 2 such problems in decision tree induction. They are model underfitting and model overfitting. What is this underfitting and what is this overfitting? See, you have a classification data, you have the training data and test data. What we thought initially, suppose you have 100 elements, you take some elements for training the data and rest of the things you will use it for testing the data. It is basically like 2/3, 1/3 or half-half. You consider 2/3 for training and 1/3 for testing, or half for testing and half for training. This is all empirical, depends on the situation and particular scenario that exists. Okay. So now the issue is you consider the errors. You have 2 kinds of errors possible. One is training error and the other is generalization error. Training error and generalization. Training error means the error that is occurred due to training samples. Okay, when you are doing this training error, during the training set, the error. And generalization error means after that you classify certain things. So that is general beyond your training part. Any error comes there out of this training set, out of that boundary of that. That is called generalization. And your idea is to see. Or 35,000 for training, 15,000 for testing you have chosen. That is fine. Using that, you will choose 1 lakh. Using the model, you will classify 1 lakh. Even that, there also the error comes, because what is the ideal thing? Whatever model you have derived and tested with those 50,000 records should fit for the remaining 1 lakh records you are totally classifying, because their class levels are not to you. Because these are the fresh applications. You do not know who is having good credit and bad credit is not known to you. Right? So to know that only ask for certain parameters, because whether he repays your loan or not, we are not a good astrologer to predict. Right? Only thing is, from the logic only you can predict, not through astrology. So now I'll explain you the reason. The reason is you are taking more number of training data, fine. So to some extent, as you take the training data, training error comes first. Now model overfitting means, because what is that you are taking, if you recollect the algorithm, because why I recapitulate the algorithm today again, to make you understand this, I have given a recap of the algorithm. What is that you are doing? You are recursively dividing. So as you keep on recursively dividing, at some stage if you stop, That is, if you say that the threshold is some 25 records, beyond 25 records you should not further subdivide. Somewhere your error rate will be some 10% or something. Okay. There if you stop, the decision tree is something. But you have your training data. You thought, no, let us again find out some more rules. Let us divide this further. So, you have not stopped with 20. Okay, among the 20 also, you thought, okay, which condition is applicable for these 20? You just brought some condition. Okay, among this, between these two, some condition is good. So, let us split it. You have split. Again, you have used another criteria. It has become 10 and 15, the 25 records. Then to fit the 10 conditions, 10 records also, you framed another condition. You have classified. And again to fit the remaining 15, you made another condition. You have classified. So, because of this, your number of rules are increasing. The number of rules are increasing. I'll show you another small picture there. So, you keep on splitting the things beyond some threshold level and seeing that the rate of classification of your training data, rate of error is 0. That means you are just fitting some criteria. But the thing is, in reality, because that sample is very small size sample. Just like that, I told you an example. Suppose you got some idea that you have to take some printouts for some assignment or for something. You have to have some 500 pages printout and you thought some 10 copies should be submitted. So with that you asked your parents for some money and you came. But later your professor said, no, you submit 2 copies, that is sufficient, you need not take 10 printouts. So for you the stationery amount and printing cost of remaining 90 pages is same. So what is that? You thought some good item is there in the deal, so you purchased it. So like that only some 5-10 people went there and you purchased. Now if I say that the person who purchases stationery and takes printout, they will purchase a t-shirt also if you say. Logically it doesn't carry any meaning, but your result will be coming like that. So that is only a very rare sample event that has happened. This is like Alva Edison saying, suppose man is not eating insects, but whereas birds are eating insects so they can fly. Okay. So it will be like that kind of wrong decision. Okay. So you should have a sufficient number of samples to go for a decision. So when you overfit this model, that is still the sample size is small, to just fit this exactly, you keep on doing things until the error is 0. Right. Oh, this worked. So this is now the training error is coming to 0. So this portion of this error part is called the overfitting problem. That is, in order to fix the error rate as 0 for training set, you keep on constructing the model in smaller data, then the model overfitting comes into picture. Okay, that's why they suggest at some threshold of the node level you stop the criteria. At least there, though the error rate is bit more, your testing error will not be that much. Okay, because see, in this angle from here the error rate is very fixed, but here that is test error rate is constant. Whereas here this is coming down. So this is the overfitting zone. Okay, this is the underfitting zone, this is the overfitting zone. So you should avoid both underfitting and overfitting problems. Okay, so for this validations, lot of care has been taken with different things. Now you come down to the slide. I hope you have understood the logic here. Okay. See, there is an error model overfitting and a model underfitting as discussed. Are two pathologies that are related to the model complexity. You can just go to the next page. That's only next page. See here, the picture is. You zoom these two. E for zoom change. Only if these two are visible, that is sufficient. You need not show the remaining bottom part of it. Okay. See, inka zoom chestara. And ade maximum. Right. ఈ ముక్క విడివిడిగా చూపించండి పర్లేదు. ఆ ట్రీ ఈ ట్రీ కింద చూపించండి. ముందర you show this tree. See, for this you have started with x2 less than 12 point something. You know the test condition anta best split and all, Gini index, so and so, so and so. Know that. You found that x2, this is the best split you found. So on that you have split it. See, now again on this, x2 is less than 17.35 is the criteria. See, in your algorithm, your F you are always sending. That means the attribute set, again, that means again and again you can split on the same attribute. Right? Depending on the condition existing there. So, once this is split, for this part, x1 less than or equal to 13.25 is the best split criteria. For here, x2 is less than 17 point. This is x1, this is x2. Okay, less than is the best split criteria at both the points. So here, with this x1 less than so and so, all pluses have come into this place. But again, x1 less than 6.56 you have used as a split criteria. Then some pluses have come into picture here. Here, now again splitting with x2 less than something, it has been split. Some pluses have come into. So some segregation has happened. Okay. And with x1, x2 less than again 1.38 or something, this segregation is happened. Okay. These are all plus classes. This is a minus class. Okay. Right. Now on the other side, your x1 less than 2.15 pluses are come. This is zeros plus 0 plus. Using these conditions, you have done this. This is how you have a decision tree with 11 leaf nodes. You stop the decision tree with 11 leaf nodes at this stage because you have fixed up some threshold number of records and you stopped the tree. Now you come to the other. In this training here, let me have a 0 error in the training data set. So he has done further split on different criteria and he brought the training error to 0. I hope you are understanding now because with 11 nodes there the gentleman has stopped and previous current to show the tree there. Okay, and x1 less than 18.08, he has stopped. x1 less than 12.9. Now come to this. Okay, x1 less than something. You have further split this. See, x1 less than 18.88. Up to this, the tree is the same. But this total branch I am showing you here is an overfit. It has stopped there with something minus and plus. Okay, This plus has come this side, whereas with this minus side, x1 is less than something. It has come to plus. You stop there, and this part also, you checked whether which is majority, zeros are plus, which is majority you checked, and as zeros are majority, you said that 0 is the thing. You stopped there, because let us suppose you checked, you found some 65 zeros and 35 pluses in this. So here you decided this belongs to 0 because majority class is 0, and you stopped it there. As in the next split, the number is decreasing, sample size. So you stopped it there. But here, this fellow felt that let us not satisfy here. Let us split all the records. So from here, this branch has come down again with minus. X1 is less than something. Then X2 is less than something is asked. The pluses have come. Again, this has become minus. This is the zeros, and some pluses. So that means here all the information is considered to be zeros here actually to this extent. But whereas here with further split, some conditions were derived to say that some records are of plus, then some condition is satisfied. But these things do not have sufficient background to say that this is equal to less than this, less than that again, to say if the rule is like this passing, okay, it doesn't have sufficient background to say this. So this part is the model overfitting part. This causes the error there. Now what happens is, if you look at these two trees, the first tree with 11 leaves, though its training error is more, this has yielded better testing results outside. Remember what I'm saying? This has yielded better testing results. This is proved to be a much better model when compared to 24 leaves model. Okay. So this has given outside a best classification. So this is the problem you face with overfitting things, because all the samples that use these rules at the overfitting part will erroneously classify, because this is not a proper representative sample of the entire stuff. So the rules derived from this, there is every chance of the remaining records being misclassified. Is it true? Is it okay for you? Are you convinced with the logic? So hence, the overfitted tree may not accurately classify the new testing records. So you should be careful with the overfitting problem. Now what are the causes for the overfitting? Couple of causes are there. We will see. Overfitting due to presence of noise is one condition. What is this? He has given a simple example here. Consider the training and test sets. Please you see the diagram. Diagram, table, sorry. Okay. See, this is an example. Here, due to noise. What is noise? We discussed before. What happens due to noise? Data will be inaccurate. Suppose 2 bits got flipped. So here what happened is, here the class label should be yes here for these two, but by mistake it went as no. So that means the noise in the training data set has occurred. So then what happens? You will derive certain rules with this condition, right? So obviously that rule will be a wrong rule and the model will be a wrong model. That misclassifies the remaining data. So that is one possibility. Then what is this actually? Because in another example also he says that. I'll quickly walk through this, because actually I thought of finishing syllabus by today, but of course maybe I think tomorrow's some I can do, because still we have to have evaluation of models. Things are there, concepts are there and all. So now if you look at, this is about the classification of vertebrates. That is, rather the classification of some animals. You want to classify them as mammals or non-mammals. So to find out whether they are mammals or, because this is a biology thing, so the terminology will be a bit cryptic. So just try to understand. The body temperature. You know certain things will be cold-blooded. See, if you look at your blood, it will be warm. You cut your hand and see, blood will be warm. But whereas certain animals and species, the blood will be cold. Generally, I have a saying, a cold-blooded murder, right? Okay, so the blood will be cold for certain certain animals, and gives birth. Gives birth means whether the baby will straight away come from the mother's womb, or you will have egg, and through egg, hatching the egg, you get the child. There is one criteria. Gives birth, yes or no. Is it four-legged or two-legged? So four-legged, yes or no. That is one criteria. Hibernates is another criteria. What is meant by hibernation? So everybody sleeps. Even you sleep in the class. Right? If some meeting is sleep, even people sleep in the meetings. A meeting is boring, people sleep. If the class is boring, you sleep. So what is this hibernation? That is sleep, no doubt about it. Right, winter sleep. That is, some animals during winter or something, they sleep to accumulate. It's a natural phenomenon. Right, good. So that hibernation is yes or no, whether it is hibernates or. So these are the names of some animals. Okay, porcupine, cat, bat, whale, salamander, Komodo dragon, python, salmon, eagle, guppy, and you have various animals over here. Then their things are there. Here, the bat and whale, they were wrongly classified as non-mammals. But whereas bat is a mammal and whale is a mammal. Okay. Now, because of this gives an error, right? It says though it gives birth and though it is not four-legged, they are mammals. They are not mammals, you get. So any other animal satisfying these two conditions will not figure out. So that becomes a non-mammal. So, but non-mammal will be, a mammal will be classified as non-mammal. So you are prone to get errors, right? If more number of records there on testing side, using this condition you have wrongly interpreted, and so that gives lot of erroneous records. Misclassification will come to picture. So that is one thing. So you just, I will show you, you can easily follow. I will show you the diagram because due to short of time I will just quickly walk through this. You can come down to the decision tree. Only we just need the diagrams from this. The logic I will explain you. Easy if I show you the diagrams. Please. Give diagrams this way. The trees to which, decision trees to which. So because of this, the classification has come like this. Body temperature, warm-blooded, cold-blooded, gives birth as no, four-legged as no, if it is just mammal, and non-mammal, and so erroneous thing has come, but it would have been like this, and you get error. Okay, next, come down. See, the body temperature gives birth and four-legged are identical to mislabeled records of the training set. That's what it wanted. So those erroneous things will be there. Next slide, please. Now, overfitting due to lack of representative samples. This is quite logically understandable. If any, in the training data set, if diagram there. This also I have explained you already, but I just want to show you an example. See, cold-blooded gives birth, yes, no, four-legged, yes, no. Next, this is the thing. Human, elephant and dolphins are misclassified because the decision tree classifies are warm-blooded vertebrates that do not hibernate as non-mammals. This is considered as a training set. So the training set is lacking the full representative samples. I have taken smaller training set because in the diagram also I have seen the graph when the training set is small. Here the problem that is caused is human, elephant and dolphins are misclassified here because the decision tree classifies. Here if you look at are warm-blooded, three things are there. This warm-blooded vertebrates that do not hibernate, they are classified as non-mammals. Here in this, using this training data set, a tree is being constructed. Show the tree. Warm-blooded that do not hibernate are non-mammals, as shown. But the human beings, they are warm-blooded, they don't hibernate. Okay, the human, elephant and all these things, they are all misclassified here because due to lack of representative samples. Those representative samples are not there in the previous 5 records. But from those 5 records, this is the decision tree that has come. Is it clear to you? So if the lack of representative samples are there, you had a misclassification. So from those 5, you check the tree construction. You will obviously know. Now it is known to you already very well. So I don't explain taking time. Okay. So this is one model you have. So overfitting and multiple comparison process from here onwards, you don't have in the curriculum. Only just those things are there. Up to this only you have the things in curriculum. The next thing is how do you evaluate the models. Next slide, please. Now we can come down. Still come down. అంతా దాటేయండి, పేజీలు దాటేయండి. ఇంకా next. He has given a lot of statistical bounds and other stuff, and it's not there for you in syllabus because for undergraduates that much statistics aspects are not needed. Right. Evaluating the performance of classifiers. Okay. You have the holdout method and all these things. What is this holdout method? Now what you can do is you load the PPT with today's date 3.2 ఉంది కదా, ఆ PPT load చేయండి. how do we obtain a reliable estimates of performance measures? So what are different performance measures and how do you get a reliable output? Next slide please. How do you estimate the model performance? What are the performance measures for? I'll just give a simple introduction and I'll stop here. So tomorrow this is the last topic. With this the model evaluation that will be over. Then I will give introduction to your next chapter, that is association rule mining. And then we can continue with association rule topics subsequently. Okay. So because you have different models for training and testing. So far I just told you simply that if you have 100 records, you are choosing either 50-50 or 2/3, 1/3 for training and testing. We are going ahead like that. But here, in such case, that is the standard holdout method. That will have a lot of limitations. That is very much prone for some errors. Okay. So now, how do you go ahead with that? So now, what is this estimating the model performance? Because it is a conventional model. Okay. This is a conventional model. And in this conventional model, you face a lot of problems. That is, you have taken two disjoint sets as training data and test data. Suppose in the training data and test data are disjoint. Okay. So there is every possibility that some of the representative samples might have come to test data. They may not have figured out in the training. So there is every chance of losing some possible conditions. So for that reason, you may miss certain things. So now, in such case, what are all different steps? Because again, if you consider more number of samples and if you consider the things seriously and go ahead with it, then you get better results. So what you do is you perform cross validations, you perform various other methods of k-fold cross validation kind of things to see that the error rate is reduced. So you will have certain measures for training data and test data taking care into consideration. You will repeatedly do the classification, and whichever model is best suited, you consider for training and testing. Now we will see what are all the errors on training data. They are also called resubstitution errors, not a good indicator of the performance on future data. And a simple solution is split the available data into training and test data sets. That's how you are splitting. Okay. Next slide please. Because of that, anyway, one thing is in this, he has dealt with one more data set he brings in between that is out of our discussion. So I will consider only to this, how the things are going on. You have the data here and you have split this as training set and test set simply, and you induce some model, you link some learning algorithm here, So learning model and learning algorithm you use. You arrive at the model, you apply the model, you have deductions, and those deductions you apply and test. Right? That is how you will do. And you apply, and if it is good, you will fix this, or otherwise you will not bother about it. Do you agree? This is the total data set. Next slide, please. Avoiding data snooping. It is important that the test data is not used any way to create the classifier. Here what is happening? You are not using the test data in creation of the classifier. So some learning schemes operate in two stages. Build the basic structure, then they optimize the parameter settings. So the test data cannot be used for parameter tuning. Of course, here he has put another concept of parameter tuning, but that I will not bring into picture because that's not there in your curriculum, because there's another some other foreign university lecture, but I found that this is good for remaining bootstrapping and other things. So, but one thing for sure is, here he has bring three data sets. One is training data, another is validation data, and test data is. But validation data concept I will not introduce, I will not bring that into picture. That is not there in your curriculum as it stands. Because at this level you are not supposed to go very deep into this. Because if you are the master level students, that is different. Okay. So, but one thing you remember, that test data cannot be used for parameter tuning. Then you just go ahead with next slide. A simple next slide. Validation part moment here. Use slide moment slide. Next slide. Yes, now we will see here. From here you have the thing in your curriculum. Only the first diagram I have shown you. This, you have a holdout method. So I told you holdout method is reserve half for training and half for testing, or reserve 2/3 for training and 1/3 for testing. That is one thing called holdout. Another is random subsample. You just randomly pick up some subsamples and say this is training and this is testing. Another is cross validation. Okay. In this cross validation, partition the data into k disjoint subsets. Suppose you have 1000 records, make them into 5 subsets, let us suppose. So each will have 200 records. Now in k-fold what you will do is, you will train on k-1 partitions and test on the remaining only one partition. So the training data will be much more, test data will be less. So leave one out of k. That is the test data sample. You do it in that. That is called k-fold cross value. What you will do is, each time you will repeat this k times. Each time one will be a data set, testing set. Remaining things will be training data. Then second one will be the test data. All the remaining are training. Then third will be test data, remaining all. That is how it cycles. That is how it cycles. Okay. That is how we will do that. So how these things have a bearing on the performance? What are the problems of your holdout method and cross validation? And there is one more thing called bootstrapping. What bootstrapping is there? Because here the things are not repeated, they are the disjoint sets. But in bootstrapping you can, suppose you choose one thing randomly, you replace it back, again you can choose it. If it randomly, so that is bootstrapping, that has certain advantages. So this discussion will postpone it to tomorrow, and tomorrow we will see how best we can do this job, and with that we conclude and go for the next one. So thank you very much. Any questions, please raise your hand or post it in your blogs. Any doubts? Type cheyandi akkada. Anything to be, any queries like that. No audio. No audio means it is a problem with them, right? Huh? Whatever. No, that is their problem actually, because as the threshold has come, the 11 leaf node, they said suppose there are 300 records, let us say. Yes, consider, yes, the majority class is 0 in that. So he said that it belongs to 0 class. He stopped. But in the second one, what he has done, no, we are getting a training error of some 10% or something, let us bring down to 0. He cut and he further classified using all the rules. But those rules are not valid because there is no sufficient background to justify what you say. Suppose I tell you in the class, suppose I have taken 2 people misbehaved. We said, oh, you people are misbehaving, something. Then, just taking about those 2, I cannot say all the third year CSC students misbehave. If I consider 50% of the students are misbehaving, then I will say, yes, this third year class is bad, they are misbehaving. But if 1 or 2 misbehave in the class, I cannot say that the class is misbehaving. Right? So it depends on the sample strength.